Okay, so before we begin, does anyone have any questions from last week's content? We'd be happy to answer any of your questions right now. Kevin, so Google Colab is just a online place to run your code basically. So if you just go to if you just search up Google Colab in your browser, you should just be able to sign into your own Google account and create your own Python stuff.
All right. So we have two different kinds of ways. I'll just kind of cover, just like very briefly, just the kind of things we did yesterday, because I think it might be a little bit relevant for what we're gonna do today. But this first line here is a list. Remember, we have square brackets to indicate that it's a list. These are just different ways of organizing our information in the code, right? So drinks, right? I'm storing each item here as a string, right? This bottom one is in parentheses. That means it's a tuple. A tuple is very similar to a list, except you cannot modify it. You cannot change and you cannot add things to it. Uh, well, that's pretty much it. We also covered how to modify each of these, right? How to modify the list, right? For example, if you want to add things, if you want to change a list item, if you want to remove something, just kind of like that. If you guys want me to delve a little bit like more in depth on that, I can do that, but just let me know in the chat and then I can do that.
Cool.
Let's see. So today we're going to be going over a cool feature called functions. Let's see. Let me pull that up here.
Ava, to answer your question, a tuple is basically a list, except you can't change it, but it works in the exact same way. Um, as a list, basically. Like
Okay.
you can like choose which specific index you want from each item, just like you can with a list, except the
Okay.
only difference is that you can't change it. You can't add more things to it.
Okay. Thank you.
Yeah.
So this is an entirely new concept that we're going to be learning today. We did use this previously, but today we're going to be making our own thing, and this is going to be called a function, right? An example of a function that we've all obviously used before is the print function. If you guys remember, we have a keyword, we add these parentheses, and then we can put whatever we want inside of these parentheses to have the computer return to us, right? If I wanted to say hello, I'd get that back to me. Okay, so we have a print function. This is one of many functions. We're going to be making our own sort of function, right? So let's say I wanted to complicate my code, right? And I wanted to make a very similar function to Python, right? To the print function that we have here previously. So I can do something like this. We're going to use the keyword called def, which is short for define, right? And then we can say whatever function we want to make, right? So I'll say printing item. And then after we have whatever you want to name this sort of function, right? We can add these parentheses. And then right after the parentheses, you can add these colons, right? Or these two dots. Then once you hit enter, you should be inside of the function declaration. Notice how my code IDE, my Google Colab added these two spaces here, or it added a tab for me. So that means I'm like inside of this function area here. Let's see. If I wanted to use this function, I could say print hello, right? And then so I just kind of made my own function to be able to print hello, right? So every time, right? For example, let me just run this real quick. Let's say my code ID realizes that this function exists, right? And now if I were to type printing item and I ran that, it would print hello. So what the code is doing is it's looking at this function here. It's looking at printing item. It's gonna check where this was referenced before, right? It notices that there's this defined printing item, and whenever it should be run, or like whenever it is called, it's gonna return or it's gonna print out whatever you want it to. And in this instance, I let it print out hello, right? And yeah, if you want to run any sort of function, you'll just write whatever you want, like the name, and then you can add these parentheses here. Another cool thing that functions let us do is they let us pass in information to the function, right? So let's say I wanted to put this here, and I'll rename this to printing a specific item. Printing specific item. Long name just for specificity, right? And what I can do is I can put in a sort of variable name inside of these parentheses, right? So let's say I wanted to name my variable item, right? I can take this variable and pass it into the print function here. So once I have item, I'm printing the item. So now if I run this, I got the check mark, which means uh, Python has read this function and it realizes it is now a function that I can use. I can type printing item, but it's a different function, specific item. And I can pass in whatever I want to here as my item variable. So I can pass in, let's say, hello Tuesday. And it's going to return hello Tuesday. So let's take a look at how this line is working, right? Hello Tuesday is being passed into printing specific item as an argument. An argument is something you will pass into a function, right? So it's passing in the string hello Tuesday into this function as an item. It's gonna go to this definition and it's gonna check, hmm, what do I do when the user gives me, or what do I do when the programmer gives me the printing specific item with an item? It's gonna check, what do I have to do? It's gonna have to print, and then whatever item we passed in. In this case, it was Hello Tuesday, right? If that makes sense. We can also print other items, right? We can print out the numbers 12.3, and we're also gonna get 12.3, right? So you just have to know that this is the def keyword. This is how you define a function, right? You can name whatever you want your function to be using this, right? You obviously, wait, I wonder. Okay. And then you can name it whatever you want. And then after that, you can pass in a sort of abstract variable that you can use inside of your function here. Let's see. Let's make this a little bit more complicated. We'll do a def greet. And this is going to take in the user's first name, and last. And now what we're going to do is we're going to take the first name variable and we're going to add this kind of space here in between. And we're going to add the last name variable as well. So we have our definition. We're defining that this line is introducing a new function that we're coming up with. We have our name of the function, which is going to be greet. And we have two parameters or two arguments that we're passing in, separated by a comma, right? So first name, comma, last name, right? And now if we run this, it's not going to run because we haven't asked it to do anything. We're just giving this information to Python so that it knows that we can use this greet function in the future, right? And now we can say greet, and then we're gonna say Mohan, and then my last name A, and it's gonna greet me. So this it's kind of based on whichever one you pass in first, right? If you pass in my last name first, it's gonna go in as the first name. But since I have my first name here, it's gonna go in here, right? And it's gonna be saved as first name in the function for like temporarily, and then it's gonna print it by replacing first name with my name, right? And one thing to keep in mind is we had to add this space here just so the first name and last name just don't get like connected together, right? Because if I weren't to add this, it just kind of like connect them together. And we obviously don't want that. We want a space in between my first name and last name. So that's why that's important to keep in mind. Let's see. Let's see. Okay. If you wanted to make sure that the order that you're using is like proper, right? You can kind of flip this, but we'll see why this is relevant in future lessons. But if I wanted to say last name is equal to A, right? And then I wanted to say first name is equal to Mohan, right? It would still work. Here in this scenario, I am making last name equal whatever my last name is, and then my first name equal whatever my first name is, just so that maybe for readability as well, but this is just another useful feature of Python. It lets us do this sort of format where we can take in whatever variable we have here, right? And we can pass that in through here. Um, I have a program that I want you guys to come up with. Can you guys try asking the user for their first name and their last name? And I want you guys to come up with like a greeting, like, hello, first name and last name. How are you doing? Or something very similar. And I want you guys to type that in the chat. And then I will go over that in just maybe 2 to 3 minutes. So just give that a go and good luck. Okay, I think I'll give this one a go. Just try and just follow along with how I do it. Let's see. So so I can save the first name and the last name in a variable, right? And I have my first input. It's asking for a user input. I can, if I want to be very careful in terms of what kind of input the user is providing me with, I can add this string just for concatenation purposes. So we don't like add a number if the user for some reason decides to add like a number for their name, right? And we can use the existing greet function here, just saying greet is equal to first comma last. It's not really necessary to add the like the equal sort of syntax here, just because it's a very simple, relatively simple function that we're using for today, so we don't have to do all that. So, and then we have a greet function, and I can type I can add a, and then it returns my name. If I wanted to turn this into like a more like personalized sort of thing, I could do this. Hello. All right. And then I add this. I can add maybe a period there. And then when I try and run this again, right, it's kind of like a greeting. It's just kind of adding extra clauses to this sort of format, right? Because we have our sort of string, we're adding a plus, we have another string, add another plus, and we're just kind of concatenating a bunch of strings together. That's how we're getting whatever we have here. Let's see. Let's try and build another sort of function. So we're gonna def addition. You guys probably get what this is trying to do. We're gonna have a num1 and a num2, and instead of printing this time, we're gonna return the number. What it does is, I'll show you guys. If I wanted to say print and then addition 1 comma 2, it would I have to run that first. It would print it out. So what addition does is think about it like when we run this sort of function, instead of printing it out, this entire function will be substituted for whatever it's going to return, right? So let's say we have our 1 and then we have our 2, right? We're adding those two numbers and then we're gonna get or we're gonna return 3. And so this entire function is going to just think about it being substituted, like in place of the addition 1, 2, it's going to return 3. So instead of addition 1, 2, it'd be 3, and then it's going to print out 3. So this is just another way to sort of have a function do something that is like meaningful for us, right? So we could do a very similar thing with subtraction, of course, if we wanted to. It's kind of doing it for me. We have our number 1, and then a number 2, and then we're returning number 1, and then number. So very similar. We have our def keyword. We have whatever we're decided to name our function here. We have our arguments or parameters, whatever we're gonna call these. We're putting them inside. We're giving them to our function to kind of ask for, and then after that, we're gonna be able to return those. So let's say I wanted to kind of use this function. I could say subtraction if I don't know very large numbers, right? Oh, so to make sure that you don't do that. So let's see what's going on.
I think you might have
My
missed.
bad at spelling. Oh, I have to run that. Good. Make sure to run each code block before you execute the following code block. We have 3200, we have our comma, and then we have this, and then these are going to be the two numbers that are being subtracted. So cool. Am I? Yeah, I should probably do it like that.
Notice how the order of the variables in your function matters. The order of which you put in your variables determines the order of what they will be in the function.
So notice how since I flipped the number two and the number one, I was getting a negative number because it was subtracting them the other way. But now that I have my number one minus number two, it's going to take whatever number I have first, and then the second number is going to subtract from that. So it's important to see, make sure your order is correct as well. Let's see. So let's say you're working on a function, right? But you're not completely done yet. What you can do is let's say I had this multiplication function, but I'm not ready to use it just yet. I can use this pass keyword to just kind of run it, but it's not going to do anything, right? So let's say I wanted to do multiplication two, and it's just not going to do anything. It's just there so that my code doesn't keep giving me the error, right? So I realize it's there. I'll maybe eat my dinner and then I'll come back to fix this function, right? Return num1 and num2, and then there we have it. We remove the pass and now it's working again. So yeah, let's see. I think that might be it in terms of functions. Do you have anything to add, Aaron?
Not really. I would say maybe just default values, or maybe
Oh, okay.
you want to go over some like more practical examples.
Okay. Yeah, I'll go over default values actually. Um,
The scope as well.
okay. Yeah, I'll cover scope. So for this multiplication function, right, we have our num1 and num2, but these obviously aren't variables, or these aren't variables that we can use outside of this function here, right? So let's say I were to do multiplication 1 and 2, right? I wouldn't be able to print out what num1 is because it's not, it's inside of the scope. It's outside the scope of the rest of the program, right? Because we have our function here, num1 and num2 are only going to be used inside of this function. And so because of that, you can't really reference it or you can't do anything with it because it lays outside the scope of the function.
You can
That's
think of
just
it, yeah, you
terminology.
could also think of it like if any of you guys here play Minecraft, you can think about whenever you have another indent, you enter another dimension, right? And that basically means that everything is new and you can't access anything in the next dimension. There is one exception though. You can access variables in previous indents and your further indents. So for example, if we had a loop, loops also have scope. Whenever you have an indent, which is basically using that colon, you can still access the variables that are basically in in a in a bigger indent or like a closer to the left. If it's closer to the left, it'll have a bigger scope, which means it can be accessed, and anything below it in scope. But the key is that you can't access anything above it. So in this case, in the function case, um, we can't print num1 because
It's
it's
only inside of the function.
yes. You can't go the other way around. If num1 was outside of the function, we could use it in the function, but we can't be outside of the function and use a variable inside of the function. It basically keeps things wrapped up nice and neat according to their indents, and this is called scope.
So okay, so yeah, we can't use it outside, but we can use it inside, right? We're able to use num1 and num2 inside of the function, but we can't use it outside because num1 and num2 are inside of the scope. Or they are, okay, num1 here lays outside of the scope of the function. So we're also going to cover default values or default variables, whatever you want to call it. So we have our defined function. I'm going to call my function default guest for now. And I have my argument that I'm passing in. And I'm adding this equal symbol to say that name is going to be equal to guest. And I'm printing out hello guest, right? And then when I run this, it's not doing anything because I haven't asked the program to run the function yet. I'm just asking the program to remember the function, but not to use it. And so now I say default guest and it's going to run without any parameters, right? Because I don't need a parameter for this to run. However, if I were to remove this, I'm going to get an error because it's saying the error that I'm receiving is default guess is missing one required positional argument name. So it's telling me, hey, you forgot to add a name to your function. But to kind of mitigate that, if you don't get any value or if you don't want to add any value to this sort of parentheses, it'll just run for you regardless, just because you have this example. Um, if you wanted to add something, for example, if I wanted to add my name, I could do that and it would still work with whatever I wanted to add. If I wanted to add Aaron, it would work. It's not Aaron. And then it would still work. It would override the guest and it would make the name equal to whatever you've provided. So think about it like this. The name is equal to guest. When you add a name, it's like saying name is equal to Aaron instead of name is equal to guest, if that makes sense. Oh. I think I think that's it for functions. I'll give it to Aaron and he can cover some other cool things.
Yeah, that's amazing. Thank you. So I'll go ahead and share my screen. Um, here you go. Okay. So Mohan taught us how to use functions, like the syntax for the functions, basically how to write them. But now we need to see some maybe more examples on how we can use this in our code. So last week we learned loops and lists, which are both very useful as we learned last week, and maybe functions can also be incorporated with those. And let's see how we can do that. So let's say, so like with lists, lists make storing a lot of variables super easy, right? Loops, they make running code multiple times super, super easy. And what do functions do? You can think of it as making writing code super easy. Because basically with a function, all you have to do is write your lines of code, right? In the function. And then whenever you want, you can just call the function again and again and again. And it's basically going to run those exact lines of code whenever you call it. So it's basically, instead of having to rewrite maybe the same line of code many, many times, you could just write it once and then call the function. So much easier, right? And combine that with loops, that's just super powerful. So let's say uh, I want you to basically print all the numbers from 1 to 100, 100 times. So that's a pretty tough question, right? So print all the numbers from 1 to 100, 100 times. So first, if I if I were to just do a loop, right, that'd be pretty hard. I can do a loop though to print all the numbers from 1 to 100. That's pretty easy. I can do a for I in range 100. Or this would actually print all the numbers from 0 to 99. So I would have to do for I in range 100, where I'm going to have to print I plus 1. So if I run that, you see that I'm just connecting to the Google engine right now. Yeah. But as you can see, I printed all the numbers from 1 to 100. So this is basically the code. I just have to run this 100 times. Now, one way to do this would be to use something called a nested loop, where I would basically have a loop inside of a loop. So if I did this, if I had a loop inside a loop, this inner loop will be executed 100 times. And if we run this, that would actually happen. Um, as you can see, we have a ton of numbers, but you could also do it a different way. You could you could define this to be a function. So let's call this maybe print 100. So my function is called print 100. And then all I have to do is run print 100 100 times. So I'll just use another loop to run it. Let's get that autofill in there. And as you can see, we'll have the same result. So this basically shows you how a function is basically condensing all of this code into one statement, one line. And this is super useful if your code has a lot more code. So let me actually show you something. So if we take a look at this, oh, this actually doesn't have anything in it. Um, maybe we can, maybe this will have something. Oh, no. Okay, well, what I was trying to show you is like a more practical example of, yeah, I can zoom in. Sorry about that. So what I was trying to show you was a more practical example of basically functions being used, but looks like I don't have anything saved, but I'll actually show you another example. So if we remember on the homework from 2 weeks ago or last week, we wanted to have, here, let me scroll down here. We wanted to um, write a program that determines if a number is even or odd. Now we can write that code, right? But the problem with that is that it only runs once. So why don't we just make it a function? So I can make a function called even or odd, and I'll take in a number, and I'll just go through my not logic, right? So if num mod 2 is 0, then we know it's even. And if otherwise, it would be odd. So I can go ahead and run that. And maybe down here, I can go ahead and call that on a number. So even or odd 10, that should return, or that should print even. And we can see that it does print even. So this maybe shows you that with functions, we can save writing a lot of code because I can just call basically this 4 lines of code with only one statement. So it's super convenient. I can basically just check every number I want without having to rewrite all of this all the time, and it would always work. Okay, so since we're working with strings a lot, I do want to quickly teach you guys one trick with strings. So let me just go down here. They're called f-string literal, so I'll write that right here. So f-string literals. Basically, it makes writing like a super complex string super easy. So this is the syntax. I would start an f-string literal with an f, followed by my quotation marks, and the f should be highlighted. And then basically all I do is I just type what I want. So I can say my favorite color is, and then whenever I want to say that, okay, I'm gonna have a variable now, I just use a bracket. So I can put my favorite color is color, and my favorite food is food. Then up here I can just define color, which is a variable to be maybe blue, and then food would be chicken nuggets. So if I run this, we'll see that it's nice and easy. It's really nice to read, and it makes working with strings super easy. So I just wanted to mention that because when I personally work with Python, I absolutely love f-string literals. They're just the best, especially when you get working with more and more variables. It just f-string literals are just so good. It's so useful. All right. So yeah, now maybe let's incorporate this with some user input. So I'm going to still use my even or odd function, and I'm going to actually use f-string literals too. So now I'm going to change my even or odd function to return a number now. So I'm gonna actually have this return the string even. and or return the string odd. And let's see what happens. So if I run that, and now let me make another program to help me out. So I'm going to say, okay, let's take an input. So let's say the user's number is going to be input here. We're just going to say, please enter a number. And then I'm going to say if even or odd happens to be even. So remember, when we return things in functions, when we call the function, nothing happens because the function basically just becomes the variable that it returns. So we need to assign it to something, or we can like use them in statements as if they were variables. So I can say if even or odd num is even, maybe I'll print, maybe I won't print even because that's kind of useless, but maybe I'll print this. Maybe I'll print that my favorite color is color and my favorite food is food. And let me actually move color and food right here. All right. Or maybe else if, elif even or odd. Well, I don't need to do that. I could just say else. I can print maybe something else. So I can print, I don't know, maybe I'll say chicken jockey. All right. So if I go ahead and run this, and let's say I enter in the number 5, what do you think that this code will do? Any insights? Well, if you thought that it would print chicken jockey, you're right. Because when we pass in 5 to our function, if we go back up here, that will return odd because 5 is odd. And since um, the function did not return even, we're going to go into this block and we're going to print out chicken jockey. And I can actually make this even easier by wrapping it in another function. Maybe I'll say def funny statement, and I can actually wrap all of this in a function. And see, that is so useful. We have functions and functions, which are pretty useful, right? Okay, so now I want to go over one last thing. This is a pretty challenging problem, but I want to. Okay, so I got a question. How do you make it odd or even? Won't it recognize it as a variable? What do you mean by that? Is it like this function up here or down here?
It's like the function at the top.
Yeah,
How would the program know that it's even or odd and not like a variable assigned to the words even and odd?
I don't know. It's even or odd. Wait, sorry. Can you repeat your question?
Like how does the program know that like when you return even or odd, like how does it know that it's like even or odd or like something you like a variable that you assigned to be even or like odd?
Oh, so basically, how does the program know if the number I put in is even or odd?
Yeah.
It's with this if statement up here. So if the number mod 2 equals 0, then that means it's even, right? Because mod
Oh,
basically
yeah.
means that the remainder is it just returns the remainder when divided by 2, and we know that even numbers when divided by 2 have a remainder of 0. So that's basically just the logic up here. Yeah. Good question though. All right, but I have a challenge for you guys now. So I actually want you to write a function that lets me input a number. So let me write that down. So write a function that lets me input a number and then prints all of the even numbers from 1 to my number. So are you guys able to figure that one out? I'll give you guys a little bit of an outline. So first, obviously, we want to define our function. So let's call it print even. And then I want to take in a number. I actually don't have to do that. I could do it inside of the function. So let's actually do that. Let's not take in anything. Let's just say that my num is the input inside of the function. Now it looks like the AI in Google is too smart because it has already suggested basically the right solution, but let's see if you guys can figure out how to do it. So you will need to use a loop and you will need to use an if statement. So yeah, I'll give you guys a few minutes to try this one out. All right, so I'll give you guys another hint. So if we want to print all the numbers from one to my number, we're gonna have to use a loop. So that would be for I in range from 1 to my number plus 1. We'll go from all the numbers from 1 to my number. Now this one is a little tricky because they asked you for numbers from 1 to my number. And if we remember, just like with lists, for loops, they always start at 0. So you can actually change what the for loop starts at by adding a number right here. If you can actually pass in two variables into the range function. See, notice range is a function as well. But I can pass in two numbers. And the first one, if I do happen to pass in two numbers, the first one would be where I start. So I can choose to start at 1. You don't have to start at 1. If you don't choose to start at 1, then you would have to work with I plus ones. But you can start at 1 and it will start at 1. And remember, for loops, they go all the way up to the number minus 1. So if I want to go to number, I need to go to number plus 1 because number plus 1 minus 1 would be my number. But if you did for I in range num, that's really close, and that's basically correct. Maybe my question was a little too hard because it was a little goofy by starting with 1. But yeah, that would be my second hint. No, let's not reveal that. I'll give another hint. So once we are looping through all of our numbers from 1 to my number, so range from 1 to num plus 1, we need to check if it's even, right? So to check if it's even, uh, I would take the mod, and with loops, the variable that the for loop automatically updates would be this I variable or whatever variable you put right here. So make sure that you check I, because I would be the number that goes from 1 to uh my number every time. So yeah, so that's what, so you have to use I here and not num, because num is not going to be changing. I is the changing variable. And then finally, I'll just finish this out here actually. So this is the last step. All we have to do is print I, because I would be an even number if it satisfies this if statement. So we do have a lot of indents here, but this should work. So let's see if this works. Let me run the function. So I actually have to call the function down here. So let's try it out. So I enter number 13. I should get all the even numbers from 1 to 13. And it looks like we did get that. 2, 4, 6, 8, 10, 12. And uh normally with functions, you don't want to have like this user input stuff in the function. You want the functions to be purely um technical based. So the way you could do that is you could basically just and make sure that you input something into your function. And then out here, I would just say, okay, my input equals this. And then I would just plug in my input to the function, and it would work out just like before. All right, that should cover functions for now. So functions, returning things, and f-string literals. Those are big idea things. So let me actually show you guys a bigger example of why functions are so useful and like all of this other stuff. Actually, I can go over this real quick. Um, we did not go over built-in libraries yet. I'll just do that quickly. So, okay, so basically, let's say, okay, I want you to generate a random number between 1 and 6. And you're like, well, that seems really hard. I don't know how to do that. And you're right, because you actually can't do that with Python yet. So you have to import something called a library. And a library is basically you just import more functions, built-in functions, right? So print is a built-in function. So is range, that's a built-in function. Um, input is a built-in function. Uh, there's a built-in function called sum. There's so many built-in functions. A built-in function called sort, sorted. Basically all of this good stuff. So if we want more built-in functions, we can do something called import, and we just have to import something called a library, which is basically just a collection of a bunch of useful functions that will just become built in once we import them. So let's say I want to or I just want to be able to generate random numbers. So I can't do that with any built-in function right now, and I also don't know how to make an algorithm to do that. So I can actually import something called random. So if I type in import random, that will go ahead and import the random library. So if we want to import a library, we use this import keyword and it imports the random library. And now once this random library is imported, we have access to all of its built-in functions. So if I want to find a random number, I'll just call random.randint, and randint is just short for random integer. And let's say I want a random integer from between 1 and 6. And I'll just assign this to a variable called x. And then I can print out x and see what happens. So it looks like x was 5. Run it again, x is 2. Run again, x is 2 again. Run it again, x is 3. And as you can see, we have the ability to do random functions because I imported something. You can also import other classes. You can import the time class or not class, library, or you can import what other things can you import? You can import the math library. So if you notice, Python doesn't have any like built-in functions for math. It only has like the basic operators. So maybe you guys have learned this, but if you have if you've learned sine and cosine, that's not built into Python, but it is in the math library. So if you import math, you have access to the math dot sine function, and you can just find the sine of a number. So if I want to find sine 90, I can go ahead and print this, and we should get, let me get rid of this random stuff here. Let me just comment that out. So we should get 0 or 1, sorry, we should get 1. Oh, this might be in radians. Okay. Okay, so if we do sine 0, sine of 0 radians should be 0, and we get 0. And then cosine of 0 would be 1, we get 1. So if we want access to these trig functions, we can have them in math. Or maybe you want something else, maybe like math dot square root. We can have access to the square root function. We can also have access to a floor function or factorial or many other useful things from the math library. So yeah, that's all I wanted to cover for libraries. And I can actually show you an example again of some real world or some bigger examples. That should be it now. It's 9 o'clock, so you guys can feel free to leave. If you guys have any questions, you can just ask them and we'll answer them. Otherwise, you guys are free to go. Thank you for your attention.
Thank you.
Nice. I think I could have told a bit better, but I'm like hella tired.
What?
I think it was good. I could have been a little bit more descriptive in terms of what functions I came up with.
It's okay. I think they got it.
Oh, because I don't know how like dumb they are or like how smart they are. You know what I mean?
Yeah. They're not very the group is a lot better.
More receptive.
Yeah.
Like, do they like talk and stuff in class?
They chat a lot and they answer the questions in the chat.
Bro, dude, the first day you weren't here, it was so like vibrant. Like they would actually like talk in the chat and stuff, right? And then they would like they asked like so many questions the first day. Are we still recording?
Oh yeah, I should probably